Everything you learned about who built one of the greatest empires in human history was based on stones and stories. Now, for the first time, we have the actual DNA of the Babylonians. And what it shows changes everything. In 2024, researchers from Harvard University and the Max Planck Institute for Evolutionary Anthropology bypassed the traditional reliance on clay tablets and broken pottery. They targeted human remains from more than 20 individuals buried in ancient Babylon and neighboring Mesopotamian settlements, dating between 2500 BCE and 500 BCE. For over a century, historians reconstructed this civilization using only cuneiform texts and excavated ruins. This project introduced direct biological evidence at a scale never before attempted. Extracting ancient DNA from this region is difficult. The hot, humid soil of the Mesopotamian plain rapidly destroys organic matter, leaving genetic material highly degraded. To overcome this, geneticists focused on the dense petrous bone of the inner ear, which shields fragile DNA. They applied shotgun sequencing, a method that shears the remaining DNA into millions of random fragments, reads them simultaneously, and reconstructs the genome using computational alignment. This technique successfully recovered high-coverage genomes, providing a direct look at the population's genetic structure. These results challenged assumptions that had guided ancient Near Eastern scholarship for decades. While these individuals offer a clear window into the past, researchers note that sample sizes remain small and subject to preservation bias. Skeletons from less formal burials often fail to yield usable DNA, meaning the current data represents a specific subset of Mesopotamian society. Yet this biological archive offers a concrete point of comparison against the traditional historical narrative. The genomic data reveals that the population of Babylon was not a single, uniform ethnic group. Instead, their genetic makeup formed a mosaic of 3 distinct ancestral streams. Geneticists identified early Anatolian farmers, populations from the Iranian plateau, and a lineage linked directly to the Caucasus Mountains. It was this Caucasus-related component that surprised researchers, making up an unexpected 30 to 40% of the Babylonian gene pool. Prior archaeological models of Mesopotamian genetics emphasized local Levantine and Zagros inputs, making this massive northern genetic signature unexpected. The Anatolian layer, meanwhile, connects these ancient people to early agricultural communities that expanded from central Turkey around 7000 BCE. This exact same agricultural lineage is found in the skeletal remains of the earliest Sumerian city builders, establishing a biological link thousands of years before the rise of Babylon itself. Beneath the rapid rise and fall of Mesopotamian empires lay a persistent, stable genetic substrate. This persistent ancestral mix across 4 millennia raises direct questions about the Genesis 10 table of nations. While the biblical text cataloged post-flood populations into neat, isolated ethnic lineages, the ancient DNA shows that these groups were thoroughly mixed long before the first cities were built, suggesting that political and cultural boundaries in the ancient Near East did not reflect biological separation. While the genetic foundation of Mesopotamia remained stable for thousands of years, a stark disruption became visible as the Bronze Age gave way to the Iron Age. By comparing skeletal remains from the Old Babylonian period around 1800 BCE to those from the Neo-Babylonian era around 600 BCE, geneticists mapped a sudden, significant genetic shift. In the earlier 1800 BCE samples, the population carried the stable 3-way ancestral mix of Anatolian, Iranian, and Caucasus lineages. By the 6th century BCE, new genetic signatures abruptly appeared in the burial records. DNA extracted from Neo-Babylonian graves revealed a substantial influx of ancestry from both the Arabian Peninsula and the Levant. This Levantine component, which made up roughly 20% of the genetic profile in several individuals, was statistically distinct from the native Mesopotamian profiles. This was not a gradual genetic drift, but a sudden spike indicating the rapid arrival of a separate population. This biological shift matches the massive, state-sponsored demographic engineering of the era. During the Neo-Babylonian and Neo-Assyrian empires, rulers systematically relocated entire populations to manage their vast territories. Documented imperial deportation policies, such as those executed under Nebuchadnezzar II beginning in 605 BCE, forcibly marched hundreds of thousands of people from the Levant, Syria, and Judah directly into the Babylonian heartland. The sudden appearance of statistically distinct Levantine DNA in these 6th century BCE burials provides direct biological evidence of these mass deportations, capturing the physical movement of captive peoples inside the soil of ancient Mesopotamia. This biological overlay directly intersects with a well-known corpus of literature. The deportation campaigns initiated by Nebuchadnezzar II, beginning in 605 BCE, left a deep imprint on Hebrew scripture, which describes the systematic displacement of Jerusalem's population. In the Book of Daniel, court narratives depict elite captive youths selected for administrative training in the palace, adjusting to foreign names, languages, and food. The prophetic accounts of Isaiah and Jeremiah record the logistical reality of this exile, detailing the long journeys, the resettlement of families, and the administrative pressure to assimilate. By the rivers of Babylon, as recorded in Psalm 137, these displaced communities lamented their separation from home. For centuries, these texts existed as isolated literary accounts, vulnerable to debates over historical accuracy and theological bias. The newly recovered genomic data from 6th century BCE burials does not serve as a simplistic proof of scripture. It does not verify individual biblical events, nor does it confirm the biographies of specific prophets. Instead, the ancient DNA provides something more subtle and scientifically valuable: a real biological context. The sudden presence of Levantine genetic signatures in the Mesopotamian soil shows that the physical world described by Daniel and Jeremiah, a world of massive demographic shifts, forced migrations, and foreign communities living in the shadow of Babylon's temples, actually existed. Science and literature are beginning to describe the same human reality. Inside the graves of ancient Mesopotamia, social status left a distinct biological footprint. When researchers cross-referenced genomic data with burial wealth, they uncovered a consistent pattern. Elite tomb construction, gold ornaments, and finely carved cylinder seals repeatedly correlated with a specific genetic signature. Near the ancient city of Nippur, a high-status burial containing lavish gold artifacts belonged to an individual with over 60% Iranian-related ancestry. In contrast, nearby commoners buried in simple pit graves with modest clay vessels displayed predominantly local, Mesopotamian genetic profiles. This genetic stratification persisted across multiple archaeological sites and centuries, showing that ancestral origin directly mapped onto social class. This division offers a concrete lens for the court dynamics in the Book of Daniel, where foreign-born captives faced strict assimilation pressures to enter the imperial administrative elite. Comparing these ancient genomes with present-day populations traces where the genetic legacy of Babylon survives. The closest living genetic affinities do not cluster around the ancient ruins, but instead lie in southern Turkey, the Kurdish highlands, and the Levant coast. Across multiple analytical models, genetic continuity with Kurdish populations is statistically significant, often yielding z-scores above 5, and carrying real weight in ongoing debates about historical homelands. By comparison, people living near Babylon's ruins in Iraq today carry much higher levels of later Arabian Peninsula ancestry introduced by migrations over the last 2,000 years. The land of Babylon and the bloodline of its ancient inhabitants have diverged over the millennia. Geneticists caution that these probabilistic affinities trace a wide arc of populations across several modern borders, rather than defining a single nation, and must never be used to assert modern territorial claims or political rights. Babylon did not vanish. Its legacy simply changed form. Today, genetics prove that its descendants walk among us, carrying a living chronicle of empire and exile. The ancient world is no longer a distant memory. It is coded in our very survival. Join the conversation in the comments below.